At 10:30 hours on October 27, 1943, New Zealand infantry hit the beaches of Mono Island in the Treasury Islands. The landing force totaled 3,795 men in the assault wave. American destroyers Phillip and Pringle laid down pre-landing bombardment. Heavy rain reduced visibility. Japanese defenders, though expecting American advances up the Solomon Islands chain, were caught by surprise at the timing and specific location. Among the first Americans ashore were members of Company A, 87th Naval Construction Battalion, along with a 25-man detachment from battalion headquarters. They brought equipment that would change how Pacific Island warfare operated. They brought bulldozers, Caterpillar D, 8 models, heavy tracked machines weighing approximately 20 tons, equipped with 10-foot steel blades designed to move earth, clear jungle, build roads, painted olive drab, manufactured in Peoria, Illinois, and San Leandro, California. Shipped 7,000 miles across the Pacific Ocean to operate on a remote tropical island most Americans had never heard of. The Seabees started the engines. Diesel exhaust mixed with salt spray and tropical humidity. The sound of heavy machinery echoed across terrain where days before only jungle sounds existed. Japanese defenders retreating inland could hear the machines working. Most had never heard bulldozers operate at this scale. 1 hour after the initial landing, something happened that would become legendary among construction battalions. Machinist mate 2nd Class Aurelio Tassoni from Milford, Massachusetts, was driving his bulldozer from the landing craft when his commanding officer, Lieutenant Charles Turnbull, told him a Japanese pillbox was holding up the advance. The fortification was constructed from coconut logs and sand, standard Japanese defensive architecture. Its machine gun had clear fields of fire covering the beach. New Zealand and American troops were pinned down. The advance had stalled. Tassone made a decision. He raised his bulldozer blade to use it as a shield against enemy fire, maneuvered around the fortification to approach from the rear, and drove straight at it. Bullets rattled off the steel blade. Lieutenant Turnbull provided covering fire with his carbine. When Tassoni reached the enemy position, he dropped the blade and crushed the entire structure, burying it and its 12 Japanese occupants under tons of logs, sand, and coral. The action took minutes. The beach obstacle was eliminated. The advance continued. For this, Aurelio Tassone was awarded the Silver Star and promoted to Machinist Mate 1st Class. His exploit appeared in military publications, was illustrated in comics, and inspired a climactic scene in the 1944 film The Fighting Seabees, starring John Wayne. The image of a Seabee astride his bulldozer, simultaneously fighting and building, became an enduring symbol of Baito, Naval Construction Battalion operations. But Tassone's individual heroism, significant though it was, represented only a small fraction of what bulldozers accomplished in the Pacific War. The real story was not dramatic combat actions. The real story was mathematics, construction speed, industrial capacity translated into strategic advantage, the ability to turn any captured Pacific island into a functional American military base before Japanese forces could mount effective counterattacks or defensive preparations. The Seabees on Treasury Islands continued working after Tassone's pillbox assault. They did not stop. Bulldozers cleared jungle for supply dumps. Within hours, American forces had established secure areas for ammunition, food, medical supplies, and equipment storage. Within days, Seabees had built 21 miles of roads across Mono and Sterling Islands. They established a PT boat base on Sterling. They began constructing an airfield 5,600 feet long and 200 feet wide, complete with taxiways, hard stands for aircraft parking, and an aviation gasoline storage farm with 5 tanks each holding 1,000 barrels. The rest of the 87th Naval Construction Battalion arrived on November 28th and joined ongoing construction operations. The 82nd Naval Construction Battalion relieved them in December. The 88th Naval Construction Battalion arrived in January 1944. By that point, the airfield had been extended to 7,000 feet long and 300 feet wide, fully capable of supporting heavy bomber operations. The Treasury Islands had been transformed from undeveloped jungle into a major forward air base in approximately 2 months. This construction timeline represented a fundamental shift in Pacific War logistics. American forces could capture an island and make it operationally useful within days or weeks. Japanese forces, working primarily with manual labor, required months to accomplish similar projects. The time differential created cascading strategic advantages throughout the campaign. Faster base construction meant faster operational tempo. Faster operational tempo meant Japanese garrisons had less time to prepare defenses for the next American advance. Less preparation time meant weaker fortifications. Weaker fortifications meant faster American victories. Faster victories meant shorter campaigns. Shorter campaigns meant lower casualties and reduced resource expenditure. The cycle compounded with each operation. The bulldozers made this cycle possible. Fleet Admiral William Halsey, who commanded major South Pacific operations throughout the Solomons campaign, understood their strategic importance. After the war ended, Halsey was asked specifically about the weapons that won the Pacific War. His answer was precise and quantified. If I had to give credit to the instruments and machines that won us the war in the Pacific, I would rate them in this order: submarines first, radar second, planes third, bulldozers fourth. Halsey ranked bulldozers above battleships, above aircraft carriers, above cruisers, destroyers, and every other surface combat vessel. He ranked construction equipment fourth among all weapons and instruments used across the entire Pacific campaign. This assessment came from a fleet admiral who commanded carrier task forces, directed naval surface engagements, and oversaw amphibious assaults from Guadalcanal through the Philippines to strikes on the Japanese home islands. Halsey watched CB construction battalions operate repeatedly under combat conditions. He understood that American ability to build infrastructure faster than Japan could destroy it represented decisive strategic advantage. The Caterpillar D-8, used extensively throughout Pacific operations, came in several variants during the war years. The 1H series, manufactured from 1935 through 1941, featured a Procel Caterpillar D 13,000 engine producing 110 horsepower. Approximately 8,000 of this model were manufactured before military requirements changed production priorities. When America entered the war, Caterpillar shifted to producing the 8R series, specifically for military applications. The 8R series represented a somewhat more austere design than previous civilian models. Non-critical materials were substituted where possible to conserve strategic resources for higher priority military applications. Optional features available on civilian models were eliminated to simplify production and reduce manufacturing time. Despite these economies, the 8R maintained excellent performance characteristics. Engine output increased to 130 horsepower through improved fuel injection systems. The machine retained its predecessor's proven 6-speed transmission. Bare operating weight increased slightly to 15.5 tons. Caterpillar manufactured approximately 9,900 units of the 8R series from 1941 through 1945. Most went directly to military service. Significant numbers were shipped to Pacific theater operations. After the war, many 8R machines found their way to civilian markets. Enterprising equipment dealers purchased surplus military bulldozers from Pacific Islands and sold them to contractors throughout the United States, Australia, New Zealand, and other countries. These surplus military machines, identifiable by specific serial number markings including US 7, indicating United States Navy 7th Fleet service in the Pacific, performed reliably in civilian construction applications for years and sometimes decades after military service ended. In 1945, anticipating post-war construction demand, Caterpillar introduced the 2U series featuring significant improvements over wartime models. Engine output increased to 148 horsepower. A new 5-speed constant mesh transmission incorporated a forward and reverse lever, reducing the number of gear changes operators needed during typical work shifts. An oil clutch system, a major innovation, extended clutch life and improved cooling under heavy loads. operating weight increased to approximately 16.25 tons. The 2U series proved extremely popular in post-war markets, and thousands were manufactured through the late 1940s. But the wartime 8R series holds unique historical significance. These machines, painted in military olive drab, carrying United States military identification markings, operated by Seabees throughout tropical Pacific islands under combat conditions, represented American industrial capacity, translated directly into operational military capability. They demonstrated that modern warfare depends fundamentally on industrial production, logistics infrastructure, and the systematic ability to build faster than enemies can destroy. One Caterpillar D8 Bulldozer, operated by a skilled Seabee, could move approximately 300 cubic meters of earth per hour under good conditions. This productivity figure came from official Seabee engineering estimates and post-war construction analysis. 300 cubic meters represents roughly 11,000 cubic feet of material. Moving that same volume using only hand tools and manual labor would require approximately 300 workers laboring for an entire day. The productivity ratio was therefore approximately 300 to 1. One American operating a bulldozer accomplished as much work in 1 hour as 300 men with shovels working for 1 day. This ratio appeared in multiple historical accounts, engineering analyses, and comparative studies of construction methods. The figure was not exact, and conditions varied significantly, but it represented a reasonable approximation of the industrial advantage American construction equipment provided. Japanese forces lacked equivalent equipment. The Imperial Japanese Navy organized construction units called Setsueitai, beginning in November 1941. These units consisted primarily of Korean and Taiwanese semi-skilled laborers, led by Japanese officers and civilian overseers. The units never achieved more than a small fraction of American Seabee capability. Japanese commanders consistently expected these construction units to accomplish tasks requiring heavy machinery, but the machinery simply was not available. Japan's industrial capacity during the war focused overwhelmingly on aircraft, ships, and weapons production. Construction equipment received low priority in resource allocation and manufacturing schedules. The few bulldozers and tractors Japan possessed were civilian models, typically requisitioned from plantations or commercial operations, poorly maintained, operating without adequate spare parts or replacement capacity, and frequently breaking down under continuous wartime use. Historical records and post-war analyses document this gap extensively. Academic sources on Japanese engineering capabilities noted that Japanese engineering resources proved tragically inadequate when war came. Engineering machinery such as bulldozers were almost completely lacking. Because of severe shortages of heavy equipment, Japanese engineer units tended to include very large numbers of labor troops, usually Koreans, who occupied the bottom positions in the Japanese military social hierarchy. Manpower and physical endurance were systematically substituted for machinery across Japanese construction operations. This substitution consistently failed to achieve required results. Human muscle cannot effectively compete with diesel engines and steel blades over sustained periods. Japanese construction battalions working on Pacific islands dug trenches by hand, hauled construction materials by hand, cleared jungle vegetation with axes and machetes, built fortifications log by log through manual effort. Progress was invariably slow. Construction projects took weeks that American Seabees routinely completed in days. The resulting time gap meant Japanese defensive preparations were frequently incomplete when American assaults commenced. Multiple specific examples from different Pacific campaigns demonstrate this pattern clearly. On Guadalcanal, Japanese forces worked for months attempting to complete Henderson Field before American Marines landed in August 1942. The airfield was barely functional when Marines captured it. The 6th Naval Construction Battalion landed with the Marines and had Henderson Field operational for American fighter aircraft within days despite ongoing Japanese bombardment. The construction speed shocked Japanese commanders who had devoted months to the same project, with significantly more limited results. On Espiritu Santo near Guadalcanal, Seabees needed only 20 days, to carve a complete 6,000-foot airstrip from virgin jungle. The speed allowed American aircraft to support the Guadalcanal campaign and attack Japanese positions throughout the Solomon Islands chain. Japanese forces on nearby islands were still working on their own airfield construction projects weeks and months later with incomplete results. On Vangunu Island in the New Georgia Group, the 47th Naval Construction Battalion landed with Marines on June 30, 1943. By 3 o'clock that same afternoon, the beachhead was sufficiently secure for Seabees to begin fighter airstrip construction. Hills were blasted and bulldozed. Ravines were filled in, leveled, and paved with crushed coral. 9 days after the initial landing, the first American aircraft landed on the completed runway. By July 18th, less than 3 weeks after the assault, a 3,300-foot runway accommodated an entire fighter squadron, including support facilities. Japanese forces on New Georgia were simultaneously attempting to complete their defensive positions, a task requiring significantly more time with manual labor methods. On Tarawa Atoll in the Gilbert Islands, one of the most brutal battles in the Pacific War occurred in November 1943. American Marines suffered nearly 1,000 killed in savage fighting to overcome determined Japanese defenders. The battle lasted 3 days of intense close-quarters combat. Yet, despite the ferocity of resistance, Seabees landing with the Marines had the shell-damaged Japanese airfield back in operation within 15 hours of the island being secured. 15 hours from combat cessation to operational airfield. This timeline was barely comprehensible to military planners accustomed to construction projects measured in weeks or months. On Saipan, American forces invaded on June 15, 1944. Marines captured Aslito Airfield, the main Japanese airstrip on the island, on June 19th. Seabees went to work immediately even while combat continued in other parts of the island. They filled bomb craters, removed shrapnel and debris, smoothed and compacted the runway surface. Stopping only when necessary to defend against Japanese counterattacks, Seabees had the airstrip operational within 4 days of its capture. American aircraft were flying missions from Saipan less than a week after Marines had assaulted heavily defended beaches. Within weeks, Saipan hosted B-29 Superfortress bombers conducting strategic strikes against targets in the Philippines and eventually the Japanese home islands. This pattern of extremely rapid construction following combat operations repeated throughout the Pacific campaign with remarkable consistency. Each major operation demonstrated the same fundamental sequence of events and similar construction timelines. On Kwajalein Atoll in the Marshall Islands, American forces landed on January 31, 1944. The assault involved complex coordination between multiple landing forces across several islands in the atoll. Seabees accompanied the assault waves. Within days of securing key positions, construction battalions had established functional airfield facilities and port operations. Kwajalein rapidly transformed into a major fleet anchorage and aviation facility, supporting subsequent operations deeper into Japanese-held territory. On Eniwetok Atoll, captured in February 1944, Seabees again demonstrated extraordinary construction speed. Despite the atoll's remote location and limited existing infrastructure, American construction forces created complete base facilities within weeks. The pattern continued, proving that American forces could project power across vast Pacific distances, partly because they could rapidly create the infrastructure needed to sustain continued operations. On Guam, combat began July 21, 1944, when the Plate, 3rd Marine Division and 1st Marine Brigade came ashore. The 25th Naval Construction Battalion and 2nd Special Battalion landed with assault forces. Seabees immediately began critical stevedoring operations, unloading supplies and equipment directly onto contested beaches while combat continued inland. During 3 weeks of intense fighting for the island, Seabees simultaneously worked on construction projects. After the island was secured, the pace accelerated dramatically. Guam was systematically transformed into the advanced headquarters for the United States Pacific Fleet, a major airbase for B-29 strategic bombers, and an enormous center for war supply operations. The 5th Naval Construction Brigade, activated specifically for Guam development, oversaw construction of massive port facilities at Ypres Harbour, extensive road networks, multiple airfield complexes, and comprehensive base infrastructure. 2 complete B-29 bomber airfields, North Field and Northwest Field, were constructed by Army Aviation Engineer battalions working alongside Navy Seabees. North Field became operational February 3, 1945, and launched its first B-29 raid against Japan on February 24. Northwest Field's south runway became operational June 1, with the north runway following July 1. The scale and speed of construction on Guam represented one of the most impressive engineering accomplishments of the entire Pacific campaign. On Peleliu, one of the most brutal battles of the Pacific War occurred from September through November 1944. American casualties were extraordinarily high relative to the island's size. Yet even during extended combat operations against determined Japanese defenders fighting from elaborate cave systems, Seabee construction continued. Bulldozers worked under fire. Roads were built connecting American positions. Airfield facilities were developed despite ongoing combat. The construction proceeded because operational necessity demanded it proceed regardless of tactical conditions. Each island assault demonstrated similar operational sequences. American naval and air forces established sea and air superiority through preparatory bombardment. Amphibious forces assaulted defended positions. Marines or Army infantry secured beachheads and advanced inland. Seabee construction battalions, often landing with initial assault waves, immediately began infrastructure development. Bulldozers cleared landing beaches of obstacles. Supply dumps were rapidly organized. Roads connected beaches to inland positions. Airfield construction began even while combat continued. Port facilities were developed or repaired. Each captured island systematically transformed into a base, supporting subsequent American advances deeper into Japanese-held territory. Japanese defensive strategy evolved attempting to counter American capabilities, but found no truly effective responses. Initially, Japanese forces concentrated on defending beaches to prevent American landings entirely. This approach failed because overwhelming American naval bombardment and air attacks systematically destroyed beach defenses before amphibious forces arrived. Japanese commanders then shifted to defense in-depth strategies, positioning forces inland to contest American advances after successful landings. This also proved ineffective because American firepower, mobility, and close air support overwhelmed inland defensive positions. By mid-1944, Japanese strategy increasingly emphasized underground fortifications and elaborate tunnel systems. If Japan could not outbuild American construction capabilities, perhaps they could make American victories so expensive in casualties that American political support for continuing the war would eventually collapse. This strategy led directly to battles like Iwo Jima and Okinawa, where Japanese forces fought almost exclusively from underground positions, extracting maximum American casualties for every meter of contested ground. But even sophisticated underground defenses showed significant limitations when confronting bulldozers and determined engineering efforts. When Japanese cave positions were located through reconnaissance or captured intelligence, bulldozers sealed cave entrances with earth, coral, and debris, eliminating defensive positions without direct assault. When fortifications were destroyed by naval bombardment, aerial bombing, artillery fire, explosives, or flamethrowers, bulldozers rapidly cleared, resulting rubble to maintain road access and operational mobility. The machines adapted effectively to every tactical situation encountered. They built roads, maintaining supply lines to forward positions. They created defensive positions, protecting American troops during consolidation phases. They constructed airfields even on islands specifically and elaborately fortified to prevent such construction. On Iwo Jima, combat lasted from February 19 through March 26, 1945. Japanese defenders under General Tadamichi Kuribayashi had prepared extraordinarily elaborate underground defensive positions over many months. They fought from interconnected tunnels, reinforced caves, and heavily fortified bunkers. The island was honeycombed with defensive works representing months of preparation. Yet even during active combat operations, Seabees brought bulldozers ashore and worked under enemy fire. They cleared ground, built roads, prepared airfield facilities. Japanese forces had spent months meticulously preparing Iwo Jima's defenses. American bulldozers were simultaneously making the island operationally useful for American strategic purposes, even while desperate fighting continued. The productivity advantage bulldozers provided created strategic implications, extending far beyond simple construction speed. Faster base development meant American forces maintained consistently higher operational tempo throughout campaigns. Each successful island assault led much more quickly to subsequent operations. Japanese forces consequently had less time to prepare defenses, less time to reinforce threatened positions, less time to adapt tactically or strategically to evolving situations. The pace of American advances accelerated markedly throughout 1944 and 1945, partly because Seabee construction capabilities enabled rapid transformation of captured territory into fully functional forward operating bases. Some Japanese commanders and intelligence analysts recognized what American construction equipment represented in strategic terms. Post-war intelligence reports, captured documents, and interrogations revealed Japanese awareness of the industrial capacity disparity. Vice Admiral Shigeru Fukudome wrote after the war that American construction capabilities were among the most significant factors contributing to Japan's defeat. He specifically mentioned construction equipment as a clear example of American industrial advantages Japan simply could not match or counter. Other Japanese officers who survived the war reached similar conclusions through their combat experiences and post-war analysis. Japanese attempts to destroy American construction equipment achieved only very limited tactical success. Japanese forces targeted bulldozers when tactically possible. Snipers specifically aimed at equipment operators. Artillery units directed fire at construction sites when within range. Commando and infiltration raids attacked equipment parks and supply dumps. Some bulldozers were destroyed or damaged through these efforts. On Bougainville, a Japanese nighttime infiltration raid successfully destroyed 3 bulldozers and killed 2 Seabee operators before being repulsed. On Peleliu, Japanese artillery fire damaged several construction machines during extended combat operations, but Americans simply brought replacement equipment forward from extensive reserves. They maintained spare bulldozers, comprehensive spare parts inventories, and pools of trained replacement operators. Destroying a few individual machines barely slowed overall construction operations or timelines. The fundamental insurmountable problem facing Japan was overwhelming American industrial production capacity. The United States manufactured thousands of bulldozers and crawler tractors during World War II. Caterpillar Tractor Company alone produced 56,306 crawler tractors across all model types from 1941 through 1945. The company secured over $570 million in war contracts. Production was continuous, expanding, and prioritized. International Harvester, Alice Chalmers, and other American manufacturers added thousands of additional machines to total production figures. These bulldozers and tractors were shipped across the Pacific as routinely and reliably as rifles, ammunition, food, medical supplies, and all other war materials. Japan possessed no comparable production capacity for construction equipment. Japanese industry operated at absolute maximum capacity throughout the war, attempting to replace combat losses in aircraft and naval vessels. Virtually no industrial resources, raw materials, manufacturing capacity, or skilled labor could be diverted to mass production of construction equipment, even when the strategic necessity became apparent to Japanese planners and commanders. Even theoretically, if Japan somehow manufactured significant numbers of bulldozers, transporting such heavy equipment through American submarine blockades to isolated Pacific garrisons would have been logistically impossible. American submarines systematically devastated Japanese merchant shipping throughout the war. By 1944, Japanese supply lines were severely disrupted across all categories. Getting heavy construction equipment to distant garrisons was simply impossible, even when such equipment theoretically existed in Japan. The Seabees, who actually operated bulldozers and other construction equipment, were markedly different from typical combat infantry soldiers. Naval construction battalions actively recruited from civilian construction trades throughout the United States. Many Seabees possessed extensive professional experience as equipment operators, carpenters, welders, heavy equipment mechanics, engineers, and construction foremen before military service. Normal military age requirements were deliberately waived to age 50 specifically to obtain these experienced tradesmen. Some men over 60 managed to enlist by concealing their actual ages. The average age of early Seabee recruits was 37 years old, significantly older than typical infantry formations. This older, professionally experienced workforce provided enormous practical advantages in construction operations. These were not teenagers or young men learning equipment operation from basic instruction. These were seasoned professionals who had operated bulldozers, graders, scrapers, and other heavy equipment on major civilian construction projects before the war. They thoroughly understood earth moving, proper grading techniques, drainage engineering, road building fundamentals, and foundation preparation requirements. When Seabees landed on Pacific Islands with construction equipment, they immediately applied years of accumulated professional expertise and practical experience to military construction requirements under combat conditions. Aurelio Tassone, who destroyed the Japanese pillbox on Treasury Islands earning the Silver Star, was 38 years old when he performed that action. Before military service, he worked extensively in construction trades. His bulldozer operation during the Treasury Islands assault was not fortunate improvisation or spontaneous luck. It represented skilled professional equipment operation applied intelligently to an immediate tactical problem. Tassone thoroughly understood his machine's capabilities and limitations. He knew precisely how to use the blade as protective shielding. He understood how to maneuver effectively on difficult, unfamiliar terrain under combat stress. His Silver Star recognized both exceptional personal courage and high-level professional competence simultaneously. Formal training for Seabees combined both combat skills instruction and construction trades education in carefully integrated programs. Camp Endicott at Davisville, Rhode Island served as the primary Seabee training center in the Atlantic region. Camp Peary in Virginia provided additional training capacity. Camp Hueneme in California, later renamed Port Hueneme, became the major Pacific training and deployment center. These facilities provided comprehensive preparation for the dual combat and construction roles Seabees would perform. Seabees learned fundamental combat skills from experienced Marine Corps instructors assigned to training duties. Marine sergeants and officers taught weapons handling, small unit tactics, defensive positions, perimeter security, and combat procedures. The training was realistic and demanding. Marines understood Seabees would operate in combat zones and needed genuine combat capabilities, not merely symbolic preparation. Simultaneously with combat training, Seabees attended numerous vocational schools teaching specialized construction trades and equipment operation skills. Camp Endicott maintained roughly 45 separate vocational schools, covering virtually every construction specialty needed for Pacific operations. Detailed courses included bulldozer operation and maintenance, road grading techniques, airfield construction procedures, pile driving, arc welding, concrete formwork and pouring, steel fabrication, carpentry, plumbing, electrical systems, diesel engine repair, heavy, equipment maintenance, surveying, drafting, and dozens of other essential technical skills. Many courses lasted several weeks and provided genuinely comprehensive technical education. The training intensity reflected operational reality. Seabees would deploy to remote Pacific islands with limited supply lines and minimal external support. They needed to construct complete bases essentially from raw jungle using whatever materials and equipment they brought with them. They needed to maintain and repair their own equipment under primitive conditions. They needed to improvise solutions to unforeseen problems. They needed to defend their construction sites when attacked. The training attempted to prepare men for these diverse, demanding challenges. The dual combat and construction mission created unique dynamics within naval construction battalions. Seabees were organized military units following military discipline and command structures, but they were also professional construction organizations led by men with extensive civilian construction experience. Battalion commanders were typically civil engineer corps officers with engineering degrees and construction backgrounds. Company commanders and platoon leaders often had years of construction supervision experience before military service. The combination of military organization and civilian construction expertise created highly effective hybrid units. This hybrid nature showed clearly in Seabee casualty patterns and decorations earned during the war. Seabees suffered casualties both from enemy action and from inherently dangerous construction work. Combat casualties resulted from Japanese attacks on construction sites, from Seabees fighting as infantry when their positions were overrun, and from Seabees conducting combat operations in support of Marine or Army units. Construction casualties resulted from equipment accidents, structural collapses, explosions during demolition work, drowning during underwater construction, and numerous other hazards inherent to large-scale construction under primitive conditions. Total Seabee casualties during World War II reflected both combat and construction dangers. Exact figures varied slightly among different historical sources, but comprehensive analyses indicated approximately 500 Seabees were killed in action or died from combat wounds. Several thousand more suffered combat wounds of varying severity. Construction accidents and tropical diseases killed hundreds more and injured thousands. The combined casualty toll demonstrated that Seabee service involved genuine dangers from multiple sources. Seabee decorations earned during the war similarly reflected both combat actions and construction achievements. 33 Seabees earned the Silver Star for combat gallantry. 5 Seabees received the Navy Cross, the Navy's second highest decoration for valor. Hundreds earned Bronze Stars for meritorious service under combat conditions. Thousands received Purple Hearts for wounds received in action. Many more earned commendations and letters of appreciation for exceptional construction work completed under extremely difficult circumstances. The decoration patterns showed Seabees genuinely fought and built simultaneously, exactly as their motto proclaimed. The construction work itself created significant dangers, even absent enemy fire. Operating heavy equipment in tropical conditions on completely unfamiliar terrain involved serious risks. Bulldozers working on steep grades could overturn, crushing operators. Operators clearing dense jungle encountered hidden obstacles, unstable ground, and unexpected hazards. Construction in active combat zones meant working without normal civilian safety precautions, procedures, or equipment. Seabee casualties from construction accidents were significant throughout Pacific operations, but the work continued without pause because the work was strategically necessary for prosecuting the campaign. By the end of World War II, naval construction battalions had accomplished construction projects of staggering scope and scale across the Pacific theater. Over 400 separate bases of various sizes and capabilities were built from essentially nothing. These ranged from small forward supply points and PT boat bases to massive complexes like those on Guam and the Marianas capable of supporting entire fleets and air forces. Seabees constructed or extensively repaired over 100 airfields across Pacific Islands. These airfields varied enormously in size and complexity. Some were simple fighter strips carved from jungle, measuring 3,000 to 4,000 feet long, surfaced with compacted coral or steel matting, sufficient for single-engine fighters and light aircraft. Others were massive bomber complexes with multiple runways each 8,000 feet long or longer, extensive taxiway systems, hundreds of aircraft hardstands, elaborate fuel storage facilities, ammunition bunkers, maintenance hangars, and complete support infrastructure capable of hosting hundreds of heavy bombers simultaneously. The Seabees built road networks totaling thousands of cumulative miles across dozens of widely scattered islands. These roads connected beaches to inland positions, linked airfields to ports, joined supply depots to combat areas, and provided the essential land transportation infrastructure that sustained all American operations. Road construction in tropical Pacific environments involved enormous challenges. Heavy seasonal rains turned inadequate roads into impassable mud. Proper drainage, grading, and surfacing were absolutely essential. CB road building techniques, developed through experience and professional expertise, created roads that functioned reliably even under heavy military traffic and adverse weather conditions. Beyond airfields and roads, CBs built complete port facilities where none previously existed. Ports required piers, docks, unloading equipment, storage warehouses, fuel facilities, and administrative buildings. Many Pacific islands lacked natural deep water harbors. CBs constructed artificial harbors using pontoon barges, floating piers, and innovative engineering solutions. They dredged channels, built breakwaters, installed navigation aids, and created functional ports capable of handling large cargo vessels and fleet auxiliaries. CBs built massive fuel storage systems essential for naval and air operations. Each major base required storage tanks for aviation, gasoline, diesel fuel, bunker oil for ships, and various specialized fuels. Storage capacity at major bases measured in millions of gallons. Tank farms required extensive piping systems, pumping stations, filtration equipment, and fire protection systems. All of this infrastructure had to be built quickly from materials shipped thousands of miles across contested waters. Medical facilities constructed by CBs saved countless American lives throughout the campaign. Field hospitals, fleet hospitals, and base hospitals built by construction battalions provided emergency surgery, intensive care, recovery wards, and long-term treatment facilities. The hospital on Guam eventually expanded to over 9,000 beds, serving casualties from Iwo Jima, Okinawa, and other late-war battles. These medical facilities required specialized construction, including operating rooms with proper ventilation and lighting, sterilization facilities, water purification systems, waste disposal, and numerous other technical requirements beyond typical building construction. Communication stations built by CBs provided the radio, telegraph, and telephone networks that coordinated Pacific operations. Navigation facilities, including radio direction finders, radar sites, and control towers, guided aircraft and ships safely. Ammunition storage bunkers protected explosives from weather, accidents, and enemy attack. Fresh water systems brought potable water to bases located on tropical islands where natural fresh water was scarce or contaminated. Power generation facilities provided electricity for bases operating 24 hours daily. All of this complex infrastructure was built under wartime conditions with constant time pressure and frequent material shortages. The scope of CB construction becomes even more impressive when compared with Japanese construction capabilities and methods. As previously discussed, Japanese construction battalions, the Setsuetai, worked primarily with manual labor. Detailed examination of their methods reveals the enormous productivity gap. Japanese construction crews typically organized into large labor gangs, supervised by relatively few skilled workers and military officers. Hundreds or sometimes thousands of laborers, mostly Korean and Taiwanese conscripts, worked with hand tools under harsh conditions. Shovels, picks, axes, and wheelbarrows represented the primary equipment available. Work proceeded slowly despite long hours and intense physical effort. Projects that American bulldozers completed in hours required Japanese labor gangs, days or weeks. Japanese construction methods did demonstrate certain strengths. Japanese engineers proved adept at utilizing local materials creatively. Coconut log construction, while vulnerable to heavy weapons, used readily available materials and required no specialized equipment. Japanese forces became expert at constructing defensive positions from natural materials. Cave modifications and tunnel excavations, though done primarily by hand, created formidable defensive positions. But these strengths could not offset the fundamental productivity disadvantage. Projects requiring extensive earth moving simply took far longer with manual methods than with mechanized equipment. Road building at practical speeds required bulldozers and graders. Airfield construction within reasonable time frames required heavy earth-moving equipment. Port facilities needed pile drivers, cranes, and excavators. The equipment gap meant Japanese forces consistently failed to complete construction projects before American attacks overwhelmed their positions. Documentary evidence from captured Japanese records reveals Japanese officers and engineers were acutely aware of this disparity. Reports to higher headquarters repeatedly requested heavy construction equipment. Requests were consistently denied or went unfulfilled because such equipment simply did not exist in sufficient quantities to be allocated. Japanese industrial capacity remained completely focused on combat equipment production. Construction equipment continued receiving lowest priority even as the strategic necessity became increasingly obvious. Some Japanese forces attempted creative solutions to the equipment shortage. Captured equipment was used when available, though American forces rarely left functional bulldozers or other heavy equipment behind when withdrawing or repositioning. Improvised equipment was constructed from salvaged parts with limited success. Alternative construction methods were developed attempting to reduce labor requirements. None of these efforts closed the productivity gap sufficiently to matter strategically. The productivity differential created compound effects throughout the campaign. American forces advanced faster partly because they could build supporting infrastructure faster. Faster advance meant Japanese force had less preparation time for subsequent defensive position. Less preparation time meant weaker defense. Weaker defense meant faster American victories. Faster victories accelerated the overall campaign tempo. The cycle continued compounding throughout 1944 and into 1945. Japanese strategic planners recognized these dynamics but lacked effective responses. Defensive doctrine evolved attempting to maximize American casualties even when ultimate defeat was inevitable. Underground fortifications, tunnel warfare, and last-stand tactics aimed to make American victories expensive enough to potentially affect American political will to continue the war. These tactics increased American casualties but could not prevent American victory when American forces could systematically build overwhelming material superiority at each successive objective. The final year of the war saw CB construction reach its peak scale and sophistication. As American forces approached the Japanese home islands, bases grew larger and more complex. Okinawa, captured in June 1945 after 3 months of brutal combat, was rapidly transformed into a massive staging base for the planned invasion of Japan. CB construction on Okinawa proceeded even while combat continued in the northern portions of the island. Multiple airfield complexes, extensive port facilities, enormous supply depots, and complete base infrastructure appeared within weeks of the island being secured. The planned invasion of Japan, Operation Downfall, would have represented the ultimate test of CB construction capabilities. Planning documents called for even larger-scale construction operations than any previously undertaken. Fortunately, Japan's surrender in August 1945 made the invasion unnecessary, but the planning revealed how central construction capabilities had become to American strategic thinking. Victory was assumed to require not merely defeating Japanese forces militarily, but also rapidly building the infrastructure to support ongoing operations and eventual occupation. The atomic bomb attacks on Hiroshima and Nagasaki in August 1945 that led directly to Japanese surrender were launched from Tinian, specifically from Northfield, built by Seabees and Army engineers. The bombers that carried atomic weapons flew from runways that had been virgin jungle approximately 1 year earlier. The Twyla bars, progression from jungle to functional strategic bomber base to atomic mission launch site in roughly 12 months, exemplified the strategic impact of American construction capabilities throughout the Pacific War. None of this construction would have been remotely possible without bulldozers and other heavy equipment. The machines were the absolute foundation of CB construction capability. Bulldozers cleared jungle vegetation rapidly. They moved enormous volumes of earth efficiently. They built roads quickly. They created functional bases from raw jungle. They turned remote Pacific islands into operational military installations at speeds that fundamentally changed the strategic calculus of the entire island-hopping campaign. The island-hopping strategy itself depended partly on rapid construction capabilities. American strategic planners could bypass heavily fortified Japanese strongpoints because they possessed the capability to capture more lightly defended islands and develop them into major forward bases very quickly. This strategy worked effectively because CB construction battalions equipped with bulldozers could create complete airfields and port facilities faster than Japanese forces could significantly reinforce threatened garrisons or mount effective large-scale counterattacks. Bulldozers made island hopping logistically viable as an operational strategy. Consider specific examples. After the brutal Battle of Tarawa in November 1943, the partially completed Japanese airfield was operational within 15 hours. Tarawa immediately became a forward base supporting operations against the Marshall Islands. The next major advance in the Central Pacific campaign happened quickly, specifically because base construction happened extraordinarily quickly. After Saipan was captured in July 1944 following 3 weeks of intense combat, Aslito Airfield became operational within 4 days. Within weeks, Saipan hosted squadrons of B-29 strategic bombers conducting long-range strikes against targets throughout the Philippines and eventually against the Japanese home islands themselves. The speed from initial combat to fully operational strategic bomber base was measured in weeks, not the months or years traditional military construction would have required. After Tinian was secured in August 1944, Seabees built massive airfield complexes. Northfield became fully operational in February 1945. Westfield reached operational status in March. Seabees constructed 6 separate runways, each 8,500 feet long, specifically designed for B-29 superfortress operations. From these Tinian runways, the atomic bomb missions against Hiroshima and Nagasaki were launched in August 1945. The entire timeline from island capture to atomic mission launch was approximately 1 year. This would have been completely impossible without bulldozers and rapid construction capabilities. The Japanese never developed effective responses to American construction capabilities. Some Japanese intelligence analysts attempted to determine what technical modifications explained improved American equipment performance, searching for specific changes to combat aircraft or other weapons systems. But the truly decisive change was not in combat equipment at all. The decisive change was in construction equipment. Bulldozers gave America an overwhelming logistics advantage that superior combat tactics alone could never overcome. After the war ended, surplus military bulldozers flooded civilian equipment markets throughout the world. Many D-8R series machines originally manufactured for military service between 1941 and 1945 ended up in post-war reconstruction and development projects. Some machines went to Japan itself as part of American occupation and reconstruction efforts. The same bulldozers that helped defeat Imperial Japan subsequently helped rebuild the defeated nation. Some individual machines manufactured in the early 1940s remained operational in various civilian applications for decades after the war. The lesson of Pacific War bulldozers extends well beyond the specific machines or particular campaigns. The fundamental lesson is that modern industrial warfare is determined largely by industrial and logistical capacity, rather than exclusively by combat prowess or tactical brilliance. Victory consistently goes to nations and alliances that can produce more equipment, transport it where operationally needed, maintain it effectively under difficult conditions, and replace losses more rapidly than opponents. This principle applied to bulldozers in the Pacific War. It applies broadly to military operations in any era. Japanese strategic planners understood this reality before the war began. Admiral Isoroku Yamamoto, who planned the Pearl Harbor attack and commanded the Deisei Zero Tau combined fleet, had studied extensively at Harvard University and served as naval attaché in Washington during the 1920s. He understood American industrial capacity thoroughly. Yamamoto consistently opposed war with the United States specifically because he knew Japan could not win any prolonged industrial conflict against American production capabilities. His concerns about awakening American industrial power were well-founded. The bulldozers proved his strategic assessment correct. The bulldozers represented just one category among many where American production exceeded Japanese capacity by overwhelming margins. Ships, aircraft, vehicles, weapons, ammunition, every significant equipment category showed similar dramatic disparities favoring American production. Bulldozers were particularly visible symbols of this disparity because they operated on contested islands where both American forces and Japanese defenders could directly observe the enormous productivity differences. The bulldozers also significantly influenced American military culture and public perception of the war effort. Seabee construction battalions became famous throughout American society. The Fighting Seabees film brought Seabee stories to wide audiences. Images of bulldozers working on Pacific islands appeared regularly in military publications, newsreels, newspapers, and recruitment materials. The bulldozer itself became an enduring American icon, representing industrial capability, practical problem-solving, and determined effort overcoming obstacles. This cultural impact extended beyond the war itself into post-war American development. Many veterans who operated bulldozers in Pacific combat zones returned home with valuable equipment operation skills and experience. Significant numbers entered civilian construction industries. The massive interstate highway system constructed during the 1950s and 1960s employed construction techniques, equipment, types, and organizational methods developed and proven during World War II. Bulldozers remained absolutely central to American construction capabilities in both military and civilian applications. Today, Caterpillar continues manufacturing the D8 in extensively updated forms. Modern D8 models feature turbocharged diesel engines, computerized control systems, GPS guidance technology, and sophisticated hydraulic systems. Current operating weights exceed 80,000 pounds. Engine horsepower exceeds 360, but the fundamental concept remains essentially unchanged from the 1940s. A heavy tracked tractor equipped with a steel blade, designed specifically to move earth efficiently under various difficult conditions. Various museums preserve World War II-era Caterpillar D8 bulldozers as historical artifacts. The United States Navy Seabee Museum at Port Hueneme, California, displays multiple examples of construction equipment used extensively in Pacific War operations. Other military and industrial museums maintain similar exhibits. These carefully preserved machines represent tangible physical connections to the war and the crucial role construction equipment played in achieving final victory. The strategic lessons remain highly relevant to modern military planning and operations. Contemporary military forces still depend heavily on logistics capabilities and rapid construction capacity. Modern engineering units, construction battalions, and civil affairs teams perform operational roles remarkably similar to World War II Seabees. Equipment is far more technologically sophisticated, but fundamental principles endure unchanged. The demonstrated ability to build necessary infrastructure rapidly in contested or hostile environments provides decisive operational advantages in any conflict. The bulldozers of the Pacific War demonstrated these principles with exceptional clarity. They proved conclusively that victory depends not only on combat effectiveness, but equally on industrial capacity, construction speed, and logistical efficiency applied systematically. They showed that wars are ultimately won by factories, robust supply chains, and the capability to transform available resources into operational capability faster than opponents can effectively respond or counter. Fleet Admiral William Halsey understood this completely when he deliberately ranked bulldozers fourth among all weapons and instruments that won the Pacific War. The machines functioned as weapons not through destroying enemies directly, though Aurelio Tassone demonstrated they could accomplish that when necessary, but rather through enabling American forces to fight far more effectively across all dimensions. Bulldozers built the airfield bases that hosted the aircraft. They built the road networks that efficiently moved critical supplies forward. They built the complete infrastructure that sustained all American operations. Without these construction capabilities, the island hopping campaign would have been logistically impossible to execute successfully. This is precisely how wars are actually won in industrial age conflicts. not exclusively through single dramatic battles, though individual battles certainly matter significantly. Not only through remarkable individual heroism, though personal courage always matters profoundly. Wars are won through comprehensive industrial systems that can produce sufficient equipment, transport it where strategically and tactically needed, maintain it effectively under challenging conditions, and replace inevitable losses more quickly than enemy forces can inflict damage. The bulldozers operating on Treasury Islands beginning October 27, 1943, represented this fundamental truth, operating at tactical level. They embodied American industrial capacity translated into immediate operational capability. They demonstrated construction speed that Japanese military forces could not remotely match using available methods and resources. They represented the unglamorous but ultimately decisive work of building essential infrastructure that makes sustained military victory operationally possible. And they represented the thousands of Seabees who operated them professionally, fought courageously when circumstances required, and systematically built the network of forward bases that enabled final victory in the Pacific War. If you found this story compelling, please like this video, subscribe to stay connected with these histories. Each one reveals how wars are actually won. Leave a comment telling us where you are watching from. Thank you for watching, and thank you for understanding that history encompasses not only dramatic battles and individual heroes, but also machines, logistics, and the industrial capacity that ultimately determines victory.